Hello everyone, I'm Teacher Al. Welcome to my channel. Hello everyone. Today our topic is about geometry problem solving part 1. The first problem, find segment AB and segment AD. How to solve this problem? You have to look for the segment AB here from A to B. So we're going to identify this line. This is a second. And the next segment AD is a chord. And the other line given is segment BF and segment FC. This is also a second. And since the segment BC complete information, so this is our guide or basis to compute the missing measurement of segment AB and segment AD. So we have to do add first the segment BF 10 plus the segment FC 8. 10 plus 8 equals 18. Then we're going to multiply the exterior segment, which is BF, given is 10. 18 times 10 equals 180 divided by 9 equals 20. So therefore our answer for segment AB is 20. From here to B, the distance here is 20. Next, find AD, our computation. Since we know the segment AB, the secant is 20, we have to subtract the segment BD, which is 9. So our segment AD is equals to 11. Next, find segment BD. So we're going to look at first where is the segment BD from this figure. So the segment BD is here. So asking for the measurement here. So our computation about this, since the given is the secant and the tangent, so we have to use the formula. Square of segment BD is equals to multiply the chord and the exterior segment, which is 27 times 3, then equals to 81. Then our next step is to find the square root of both sides. The square root of segment BD, we're going to cancel this, and the remaining is segment BD, and the square root of 81 is positive and negative 9. This would be our answer for segment BD. We're going to neglect the negative, so we're going to concentrate on positive result of the square root. So positive 9. Next number 3, find the segment CF. So we have to do is to locate the segment CF from the given circle, and the given now is chord AB and chord DC. Then we're going to look at the segment CF is here. There is no measurement. To solve for the missing CF measurement, so we have to use segment CF equals, we're going to multiply the segment AB 10 times 6 equals 60, then we're going to divide by 12. Then the result is the segment CF now is 5. That's our final answer. Next, number 4, find the segment AC. So we're going to locate here the segment AC, and this is a triangle, so segment AC is a hypotenuse. So since hypotenuse, and we have the given here AB is 4 and the CD is 6. This is perpendicular, so when we say perpendicular, so it acquires 90 degrees both sides here. So perpendicular means divided the segment also into equal parts. That's why to find the CB is equals to 6 divided by 3 is equals to 3. So the measurement of CB is 3. Now identify that CB is 3 and AB is 4. So we can use now the formula of Pythagoras. The original formula of Pythagoras is C squared is equals to A squared plus B squared. This time, since we're using a segment, we have segment AC squared is equals to segment AB squared plus segment CB squared. Then we're going to find the value of segment AB. The segment AB we have 4, then the squared plus the segment CB, which is 3, so 3 squared now. Then we're going to extract the exponent. 4 times 4 equals 16, 3 times 3 equals 9. Then we're going to add 16 plus 9 equals 25. And we're going to square at both sides in order to eliminate the exponent. Here, we're going to eliminate the exponent here. Remember, in the square root, there is a silent index to here. Eliminated now, so the remaining is AC. So segment AC is equals to the square root of 25, we have positive and negative. The square root of 25 rather is equals to positive and negative 5. Our answer is, we concentrate on positive result. So we have now this AC, which is the hypotenuse of a triangle, is equals to positive 5. Okay, number 5 questions. Given segment DF equals 10, arc D equals 120. First, we're going to locate the segment DF. So this segment is equivalent to 10. Then the arc DE is 120 degrees. Now find segment DC. So this is here. Since this diameter and perpendicular, so once perpendicular, so meaning to say this segment is divided into equal parts. So the DF measurement is 10 divided by 2, so DC is 5. So our answer for segment DC is equivalent to 5. The next, find the arc DB. Arc DB, so is here. So if this is given, D is 120, the diameter, this arc is 180, 180 minus 120, so this arc is 60 degrees. So that's why arc DB is equals to 60 degrees. Next, arc BF. So this one, arc BF. So to find the arc BF, so we're going to, our basis is the diameter AB. So the arc of the AB is 180 and the arc of D is 120. So therefore the measure of EF is also 120. Then the diameter is 180. The arc is 180. So 180 minus 120. So BF is also 60 degrees. Arc EF, so is here. Arc EF. If D is 120, D is 120. So therefore the other side, because this is congruent, so 120 also, 120 degrees. So arc DEF, so major arc. So if this is 120 plus 120, so the arc DEF is 240 degrees. Next, measure of angle DGB. So DGB, so this angle, the vertex of this angle at the center, so this is called the central angle. So the measure of central angle is equivalent to the measure of the arc. So the arc DB we have 60 degrees, so therefore the measure of angle DGB equals 60 degrees. Next, number 6, find arc DB. So we're going to locate the arc DB. Is here. Arc DB is the minor arc, and we have to determine the given. We have the angle C is 30 degrees and the arc FA is 110. To find this small arc DB, we have a solution. Arc DB equals 110 minus the product of 30 times 2. So 110 degrees is equals to 60. 110 minus 60 equals 50 degrees. So the arc DB is equals to 50 degrees. Next, number 7. This is the given circle, given second line, and also second line intersecting each other, and we have the 20 degrees angle, and minor arc at 30 degrees, and we have also, this is to find the arc X. To find the arc X, we're going to use this solution. We have arc X is equals to, we have to multiply by 2 this angle, 20 times 2, then we're going to plus the minor arc 30 degrees, then 20 times 2 equals 40 degrees plus 30 degrees. So this big arc here is equals to 70 degrees. Our answer for the X is 70 degrees. And next, number 8, the given second and also second line here, and the missing is the angle. So we're going to find the X, this angle, and the minor arc is 20 degrees. We have here a big arc is 120 degrees. Our solution is angle X is equals to 110 minus 20. We're going to minus this one, 120 minus 110 minus 20 equals 90 degrees. Then we're going to multiply by 1, then divided by 2. So the result is the angle X is equal to 45 degrees. Okay, number 9 problem. Find the X. So we have to look at the X is here. It's an angle. So we're going to determine what angle is this. So the line here is called the secant, also the secant intersecting each other, and form an angle on the circle. So therefore, if the vertex is here, the vertex of this angle, so this is called inscribe angle. To get the measurement of this angle, we have this angle is 1/2 of the intercepted arc. So our computation is angle X equals 1/2 times 80 degrees. 80 times 1 equals 80 degrees divided by 2. 80 divided by 2 equals 40 degrees. So this angle X is equals to 40 degrees.